Okay, I just got a text message, so it ended it. So we found the z-score for this thingy. I'm glad I even remembered that it canceled it when I get text messages. So I have that z-score. Did you do that, Taryn? No. That thingy. I might have to find it. I bet it's already done for us somewhere. Okay, so, oh, whoops, we didn't really draw our quick graph. There it is. 1 is less than that. Cool. 6, 7. Yep. Find the area to the left of negative 267. When you look at it, you should get 0.0038. Okay, so now what it actually asked about was if 500 people, how many will drink less than 1 cup of coffee a day? So now we have to transfer. We had this number, whatever that is, whoops, not 5,000, times 500, 0.0038. And I have a feeling that the math is already done there. Okay, you get 1.9. So if you had 500 people in a room and that was actually like the real data from it, sometimes we just make up random stuff. So if that was actually real, we would expect about 1.9 people to drink less than a cup of coffee. Okay, we're asking about people, so round to the nearest 2 people, approximately 2. Okay, if you can count in decimals, go ahead. If it's something we can't count in decimals, like people or rabbits or whatever else, make sure you round properly. Okay, more examples, if I can get there on this thingy too. To qualify for the police academy, candidates must score in the top 10% of the general abilities test. The test has a mean of 200, so that's my mean, and a standard deviation of 20, that's my sigma. Find the lowest possible score to qualify. Assume the test scores are normally distributed. So what this guy is gonna look like is we don't actually know the score, so when we're looking for z-scores, we usually have z equals x minus mu over sigma. We're actually looking for x, which is a little bit different, but we also don't know our z-score. They don't give us our z-score. The only thing they give us is our percentage, so we have to use this percentage. So what that looks like on a quick thing, okay, I have 10%, top 10%, I know it's gonna be over here. Okay, what number, where am I gonna look? Am I gonna look on like that right or that left-hand page for that guy? Does that make sense? On the right-hand side, but the right-hand side asks about this. So what do I need to do to that 10%? Okay. Okay, I need to change it to what's actually less than 90%. Okay, so top 10 equals to bottom 90. Okay, so you're gonna go in here and you're gonna find the closest thing to 0.9000. So I don't know where that guy is either. 0.9. But actually, if you look at it, the 0.8, yep. So we're gonna always pick the one that's closer. If it's actually in between, I think there's a couple that it's actually in between. I think you pick I don't know, that doesn't happen very often. So now I don't know. Actually, I might have to look that up. So that is the closest thing. That thing has a z-score of what? I've lost it. 128. I think so, yeah. So that z-score is 1.28. I said that wrong. Okay, so now that I found my z-score from looking at my chart and going backwards, I can plug it into this formula. So I have 1.28 equals, I still don't know my x. My mu didn't change, so minus 200 over my sigma of 20. Okay, now it's just a matter of algebra kind of skills in there. So what we're doing there is 128 times 20. 25.6 equals x minus 200. We're gonna add 200 to that guy. Okay, so 225.6 is equal to x. I probably might be able to get that on a test, so I would think that's an acceptable thing for a test score. It depends, they might want whole numbers for tests. Okay, it might be a rounding error or something when you're checking your answers. So I would need a 225.6 at least to get into the police academy. Okay? So that one kind of is a little bit more steps in there. So it kind of has, we kind of walk through all of that. Okay, so now we're going to do, oops, did I go back too far? Okay, for a medical study, researchers wish to select the middle 60% of the population based on blood pressure. If the mean systolic blood pressure is 120 and the standard deviation is 8. Okay, so that's going to be same sort of problem that we're going to do. Thing you need to think about more is when I do my little graphy deal, I have my middle. I know what my middle is. Don't really care that much about it. But now I need to find, hey, where's 30% or 60%? What 60% is going to look like in here is 30 right here. So now I shouldn't have colored all that in. I have a 30 here. I have a 30 here. Now I need to do kind of some more like finagling around. Is that a real word? I think it is. But I think it is. We're going to look it up later. Finagle. I think it might be a real word. Okay, so what we're going to do is, hey, this is definitely 50% without caring so much about the numbers. We're just caring about those percentages, which is all those giant numbers in the table. Or really teeny tiny, however you want to think about it. So I have 50, I need 30%, so what I need to find here is the bottom 20%. Okay, for this one, hey, I'm going to do 50 plus, it's a word? Yeah? On what? Do I want to know what Urban Dictionary says it is? Okay, okay, that's what I was wondering. Okay, this guy is going to represent the bottom 80%. Okay, other ways to think about it is I could think about it as, hey, if there's 60 here, there has to be 40 left. That 40 has to be split into bottom 20. Okay, top 20. So what we're going to do now is we're going to use our little chart to find the closest numbers to 0.200 and 0.800. 0.2 is over here. Is it bad? Is it that bad? Yep. Really? I didn't expect that. Okay. I've never, I did not mean it as theft either. Oh, okay. I think it has to be a real word. Okay, so negative 202 has a z-score of negative 2.05. And probably, so 8.0. Okay, get back here. Oh, am I looking for the wrong thing? I was looking for, that is the wrong number. Totally the wrong number there. I want 0.20, not 0.2. 0.2. Do you see a 0.2? I have a 2005. Anybody see anything different? So when I'm on my little chart, dude, it looks like negative 0.84. And the bottom 80% should also be just positive 0.84. Okay, you all right? Yeah, that'll be good. Okay, positive 0.84. Cool, that works out. That's 0.7995. And that z-score is positive 8.4. Okay, so if you're the same distance away from the median, median, everything, they should be the same numbers. Okay, so middle, that's kind of what you get to do. I don't know, I think that's a weirder thing to remember, so just remember how to look it up more than anything. So what's that going to look like? So now we need to find our z-scores for that thingy. So look at that, it does it kind of for us. area to the left of it is 0.8, so yeah, that works out. Okay, this is not what I wanted. Okay, we have negative and positive 8.4. Totally didn't stop where I wanted it to. Oh, so now we have to go back, and I have no idea what they kind of did there. Okay, so now I have my z-score, so I have my normal z is x minus mu over sigma. So what that guy looks like is z-score is negative 0.84. I'm looking for, I wish I would have put the problems up here so that we could keep reading it. I'm looking for x minus my mean was 120 for my systolic, and then my standard deviation was 8. So you can kind of skip to this piece that they have right here. So they don't always write it out like that. I think that's weird because then you have to remember another formula. I would rather remember one formula and be good at the algebra. I think that's easier for me, but I like algebra a lot. So that times that, I don't know what that is. Do I have a calculator? Negative, or 8 times 8.4, 0.84. Negative 6.72, and then we're going to add 120 to that. Boy, I can't write anything. 113.28 is equal to my x, so when we add 120. Okay, we're going to do the same thing to this guy with a positive 8.4, or 0.84, sorry. What that guy is going to look like is just slightly different numbers because positive and negative pieces. So hey, I'm going to get a positive 0.62 equals x plus 120 minus 120. Then I'm going to add 120 and get 126.72. I don't know, I mean, like, this is a nice way to type it in your calculator, but I don't know. I don't like trying to remember more and more formulas. Okay, so round it. Nobody's ever given you've never had a nurse or a doctor take a blood pressure that was a point this, so it doesn't happen. So 113 and 127. Okay, round properly. A normally distributed or bell-shaped distribution is only one of many shapes that a distribute can assume. However, it's very important since many statistical methods require that the distribution of values in subsequent chapters can be normally or approximately normally shaped. Okay, we check for normality on some things. So yeah, so not everything is normal. Not everything is this normal thing. So from now on, when we actually say normal, I totally mean this. I don't mean like, yeah, you're weird because you're still weird. It's okay. We expect it. Okay, we can make a histogram really easily. A histogram, just a quick, hey, does that look like it goes down and then up and then, okay? PI index of skewness. Outliers, so we can check for outliers. We already know how to check for outliers. A normal quartile plot. So remember how sometimes if things were skewed, you might have like this little tiny box, but then we'd have like a really long piece. And then outliers would look like that somewhere. We don't want those things. Because remember, outliers affect the mean a lot, so we don't want that happening. Okay, chi-squared goodness of fit test, Kolmogorov-Skoromarov test, and Lillie-Forrest tests. Let's use one of them. Okay. So in example 611, so I'm kind of turning my page there too. It has technology inventories. Okay, there's lots of different things it makes you kind of do. Does it tell you where that Pearson coefficient thing is? Okay, we can do, I'm going to write down that Pearson coefficient thing. And it is just PC equals X bar, which is the sample mean, 3 times that. X bar minus the median all over S, which is the standard deviation. for this sample. Okay, those are those pieces where we're using the calculator to come up with those data. So if it is